My name's CRob. I work in an organization called the OpenSSF. We are a project of the Linux Foundation. I have been doing security stuff on the internet for a long time. I am also a recovering super regional engineering and operations manager. And I have not done that for a while, but I absolutely empathize with folks in financial services. I lived your lives for many years. I got the great opportunity to work every holiday for 7 years while I was there. Thanksgiving's a great time for things to go down. I represent the Open Source Security Foundation. Broadly, we're an industry group of about 125 organizations, and we are dedicated towards improving the security of open source software supply chains, and now AI software supply chains for the ecosystem. We've been around since 2020. I have had the great pleasure to have first been a volunteer for the first 4 years of our existence, and then for the last year, I've actually been a staff member of the foundation. We're focused on many different slices of security within the open source ecosystem. Generally, you can line our work up to a DevSecOps pipeline model. We have a ton of projects and working groups focused in on the developer, teaching them how to write secure code, providing them tools and guidelines on how to use different techniques or different security options within language ecosystems. We do a lot of work within securing source codes, build systems, and then as you get out to how it's packaged and delivered. And then ultimately, we have a lot of good guidance for downstream consumers. Banks especially, my time at the bank, we really rarely considered ourselves a financial institution. We felt we were a technology company that also helped people pay their mortgage and finance their dreams and whatnot. And then we also do a lot of work around vulnerability information, which is what our topic is today. We talk about looking at dependencies. We give guidance on how to select secure packages and whatnot. So if you're curious, we have 10 working groups. We have over 22 different software projects or specifications, like SALSA, which is one of our supply chain specification. So if you're curious, we have a great body of work. OpenSSF.org is your gateway to get to our materials. So the topic around CVE. CVE was created 25 years ago to try to provide a common language for risk, a common viewpoint and perspective, so that as you see modern software is developed, you'll have some third party, maybe an upstream maintainer, create something, and then gradually throughout the supply chain, different vendors or different organizations will take that software, package it up as a product, and deliver it downstream. If you're a bank, you probably have thousands of developers, so you may be potentially picking between like a vendor, like a Red Hat SUSE Canonical is providing you packages, but you also may grab stuff upstream. And what CVE, the numbering allowed people to do is CVE describes a unique vulnerability, and it allows everyone that leverages that particular component to express, I am vulnerable to this. This is kind of how my particular product or service is affected. And again, it allowed downstream and developers to kind of understand when you say CVE 2025, 1, 2, 3, 4, oh, I understand that that's a cross-site scripting bug in Apache on the web server or whatnot. So it allows everyone to kind of understand, have that common understanding of a unique problem. CVE only describes a vulnerability. And the program used to stand for Common Vulnerabilities and Exposures. The board has gone through some debate over the years about what it's called, but basically it's Common Vulnerabilities and Exposures is how most people use it. But that's just one of the tools within the ecosystem that help describe vulnerabilities. You have another tool called CWE, the Common Weakness Enumerator. This actually describes the root cause of why the vulnerability exists. This was the coding or the logic flaw that made this vulnerability happen. And then you have one of my favorites, CVSS, that's the Common Vulnerability Scoring System. This is a methodology. It gives you a score for prioritization, but that's the least interesting component of that methodology. The most important aspect of CVSS is you're given a string that describes exactly how that vulnerability is executed, what types of impacts could happen, and how CIA confidentiality, integrity, and availability are affected. So the string within CVSS is the most important thing. But you'll see these three tools commonly used, and if you're looking at a resource like the NVD, you will have all this information there for you, along with some additional enhancements. So again, why is this enumerator important? It provides one specific problem and identity, and it allows researchers, maintainers, downstream regulators, governments, again, it gives them the ability to use this one phrase to describe that vulnerability, no matter what platform or vendor may be affected by it. All of these methodologies have become kind of foundational for cybersecurity frameworks like NIST 853, or you'll see like within PCI references to CVSS and having your vulnerability management, have a vulnerability management practice. But these all work together, and ideally, as a downstream consumer of software, you take these elements, you kind of apply your risk calculus, your risk appetite, your risk tolerances, and you provide your own score and prioritization to kind of motivate your organization to react. But these are all, these ideas and concepts are baked into both cybersecurity frameworks and international regulation, like my favorite friend, the CRA. And many of you are representing internal organizations, so your CCERT, your computer or corporate security incident response team, your InfoSec group, those are the people that should take this. They should be doing their own risk assessment and then working through your organization's processes to encourage people to patch quickly, depending on the severity and like the systems or data that could be affected. This is a very simple workflow of how the system works today. You'll have some type of finder. That could be a security researcher, it could be a hacker, it could be a user. Many of you may find vulnerabilities and report them back. Generally as a bug report at first, I'm getting some weird behavior, and then if you report it to the vendor, they might figure out it's actually a vulnerability. So that goes to a body called a CNA. A CNA is a CVE numbering authority. That is a group that is responsible for some hardware or software or sets of hardware and software, and they're responsible for helping organize and put the data together. And generally you think of it like a vendor, or in the case of like the Linux kernel, that's the maintainers that are responsible for that particular software. So the CNA is responsible for making sure that there are 4 data elements put into the record, and that goes into a thing called CVE list. And your CVE record has the ID, which is always CVE-year-numeric string after. You have a description of what the problem is. You have a reference where you can find more information. So if, for example, Red Hat Product Security is managing this bug, they'll have a link to their advisory database where you can go learn more information. And then finally, it gives information about who the CNA, who's the responsible party for this particular aspect. Then it moves downstream to a different system that most of you, this is what you're probably leveraging today, the National Vulnerability Database. This is run by a different government entity. The CVE program is run by CISA, the US's cyber defense agency. NVD is run by a different government group called NIST. And the NVD, you'll have an analyst, generally somewhere in Wyoming or Montana, and they will enrich the CVE record, adding additional information like a CPE, which is basically, it's called Common Product Enumerator. That's the name of the software. And then they'll add in CVSS scores and other additional information. So this is enhancement, and that's generally what downstream CCERT teams, InfoSec teams, will leverage the data from the NVD. Sadly, NVD historically has had the most complete vulnerability data on the planet. But one thing that most consumers and most people in the ecosystem don't understand is both of these programs, CVE and NVD, are focused on hardware and software that the US government uses. Full stop. Their mandate is not all hardware and software. So if you're using a product that may not be sold to the US government, and the US government is one of the largest procurers of hardware and software on the planet, so they have great coverage, but it is not 100%. And they never claim to be 100%. And they are very opinionated in what they put in there because this is from the aspect of protecting US citizens and US critical infrastructure. And that's the perspective they go into. So that's why sometimes you'll see the severity ratings may be higher than you would expect because potentially this software is used in a nuclear reactor or water treatment plant or in some DoD thing. And neither program claims complete coverage over the ecosystem. NVD, everyone assumed it was a global database, but really it is just a vulnerability database. There are many others that exist in the ecosystem. It is run by NIST, was established in 2005, and for a long time it was the most complete aspect, a one-stop shop where you can get information. But again, they never intended it to be a source of everything. And then last February, they had a problem where all of that extra enrichment data, like for example, the CPE, which is the product name, vendor, version ID string, was no longer being added into the database, complicating downstream's ability to be able to understand what does the CVE affect and how do I need to take action. So this was a copy of a banner they had on their webpage. Says that, well, we're working to create a consortium to get people ecosystem together to help us enrich this data. It is October 22nd, 2025. I'm still waiting for more information about that consortium. This is a little chart showing you way back in 2024, essentially every record was being enriched. Not necessarily at a speedy cadence, but generally anything in that database was being enriched. And you'll see progressively as the volume of CVEs went up, the trend line of the enriched data started to move towards a flat pattern, and there's right now a substantial gap. It's about a 20,000 record gap right now between what exists in CVE and what exists in the NVD. And the story gets even better. This April, we experienced something amazing that our friends in MITRE, who is the entity that is the administrator of the CVE program, a memo got leaked that they sent out to the board stating that the CVE program no longer had funds and they were going to be shuttering it and CWE. This came as a shock. I got this announcement 2 days after we had government representatives at a security conference talking about the program and vulnerability ecosystem. CISA had an amazing statement where it says the program is invaluable to the cyber community and is a priority for CISA. And CISA stepped in and they were able to provide the funding to continue the program, whereas MITRE had said the funding was threatened. Then, the day after the leaked memo, we got this exciting nonsense where a substantial portion of the CVE board left the organization. They created their own nonprofit foundation called the CVE Foundation. And they were saying, we will be the spiritual custodians of CVE as the US government kind of has funding challenges. And then I think 2 days after this, MITRE filed a patent on the word CVE. And so we're still waiting to see kind of how that affects a organization that has a copyrighted and trademarked word as their name. And then it gets even better. After months of silence, so this was back in April, and as this happened, upstream maintainers, vendors, downstream consumers were at a loss. Like this system literally helps me run my business, helps me stay compliant with my auditors, whether it's PCI or you're talking to the Fed or whomever. So this just came out about a month ago that CISA said how important CVE was to them and the nation, and they care a lot, and they're going to do some stuff in some unspecified time frame to help make it better. So that is the sole extent of the public communications from both of these organizations. And actually, my friends at CISA got a little snarky where they said that private entities probably have too much of a conflict of interest to be able to run this, whereas the US government never has a conflict of interest. This is how I observe the situation, where we have a group of people kind of fighting over toys in the playground. There always has been gaps with the program. The program was imperfect. The data that most CNAs gave was not complete, was inaccurate at times. NVD is not being enriched and definitely not being enriched quickly enough. Sometimes, like their current cadence, it could take weeks to months for them to get you that critical information for you to make your own internal assessments to take action to support your vulnerability management goals. The program services are not tailored to how modern software is developed. It's very much rooted in the heritage ecosystem of products and very much follows a waterfall style mentality, not a agile developer-focused thing. They don't have tools, they don't have support to make the developers have an easy onboarding into this. CVE was a vulnerability enumerating system. There are several others. OSV, the open source vulnerability database, is a project from Google that we partner with. The Europeans are making their own vulnerability database, which is noted in the CRA law and several other laws over there. So they are mandated they will have a European database. China has had a vulnerability database for 6-8 years where any citizen is compelled to report a vulnerability to the Chinese government first prior to disclosing to a vendor. You have the global security vulnerability database, you had the global security database. So there's a bunch of people that do this work today and that aren't CVE. And CVE predominantly is focused on commercial entities, commercial products and services, and they have had very little love and attention to open source projects. So here's some quick fun facts. Looking at the CNA list, there are 470 entities. They're predominantly manufacturers, but there's some researchers and some other organizations like bug bounty people in there. Of those 470, 205 mention open source in their scope somewhere. Looking at that list, I'll generously say 56 of them are truly participants in the open source ecosystem. And this is kind of just most of their scopes say that they will cover products and vulnerabilities in third-party software discovered as part of their offering. Now, what about open source? There is no number of how many open source projects there are on the planet. The best data I have is from GitHub. And last year's State of the Octoverse report, they stated that there were over 518 million repositories in the GitHub ecosystem, and GitHub houses about 80% of open source software. GitLab does between about 15%, and then you've got a couple other repos that would house software. So I'm not a mathologist, but I'm pretty sure that the 205 people that said they do the open source is less than 518 million. It's just a guess, though. I'm going to go out on a limb on that one. So some fun facts about the open source. I chunked it up into 3 different categories of projects. First off, you have large, very mature projects. These are things like Kubernetes, anything from the Apache Software Foundation generally, Linux kernel, and this is where they have a dedicated team of security people that do the work. Out of all the software, you've got, I would say, probably a couple dozen projects that fill into this bucket. The next bucket are what I would term medium-sized projects. These are projects that have more than one developer on the project. These folks generally have between 4 up to 100 people that participate in the project. There are hundreds of those projects where you probably can talk to somebody that knows something about security. Then you've got several hundred projects, 518 million minus several hundred. That's everybody else. There are honestly millions of single maintainer or unmaintained packed projects out on the internet that you may be incorporating into your enterprises. And generally these are spread across the ecosystem, but this is a large amount of risk that organizations take on as they incorporate components, because those projects may not have a security capability, they might not have tools, they might not have a policy or a way to talk to them, they might not participate in vulnerability disclosure. First half of this year, we saw a 16% increase in CVE. Generally, that goes up about, when we get towards the end of the year, it'll be close to 45 to 60% increase year over year, the program sees. So we're getting more data piped into the system. About 86% of all commercial code bases contain substantial pieces of open source software. Like my friends at Sonatype and others do annual reports, so depending on which report you're reading, the majority of software contains open source. And one of these studies cited that some applications will have up to 900 package dependencies, which is a lot. So you may be downloading and using Log4j, but you're also getting a series of frameworks and libraries and dependencies that come along with that to make that software work. So there is a huge gap between those that are creating the software and those that are consuming and reporting about it. And from a financial perspective, this capability is a strategic necessity. You have to have the ability to assess problems within your products and services to protect your customers, but also, your regulators, whether it's the FDIC, the FFIEC, whomever, the comptroller, whoever you're reporting to that day, they require you to be managing vulnerabilities. And this instability has eroded global trust. The day after the MITRE letter went out, the Europeans raced out their database to production. They were planning on releasing it around this time frame, but they rushed it out in April just so that they had such fear that this capability was going to go away that they wouldn't be able to advise their citizens. And this really complicates incident response, where you have two practitioners talking to each other. I need you to fix this problem. It really makes it very complicated if you don't have that common language, that foundation to share back and forth. The banking regulations, they all require you to be doing vulnerability assessments, penetration testing. Both of those are based off of a vulnerability enumerator being identified and shared. You are required to do continuous monitoring. You must be doing risk-based remediation. How can you accept or mitigate a risk if you don't understand how it works or where it might be? And there's also a cascading effect that you probably all rely on commercial scanners or open source scanners to help you find this information. Those are all downstream of the CVE NVD ecosystem, so they're not getting that accurate data. So your assessments aren't timely, and you're potentially exposing your organization, your customers to an unknown risk. Some of the top global regulations, I'm sure everybody loved when GDPR rolled out, but we have things like SOX, PCI, I believe it's Britain has the Bank Secrecy Act. You have Graham, Leach, and Bliley here in the States. You had the PSD, which is a European regulation. You have DORA, which is their newest banking regulation. And then if you look at the FFIEC examiners handbook, they provide you a list of relevant laws that sometimes breaks it down nationally and then at a state level. So you all have a lot of requirements, and most of these hinge upon being able to find and fix vulnerabilities. And if you can't get that accurate data, how are you going to meet these obligations? Hey, it went black. That's cool. Aha! Well, somebody is doing something about it. Yay! A couple of months ago, when this happened, we partnered with our friends at OWASP and several other upstream open source foundations, kind of writing an open letter to all the children of the playground. This is important for us. Our constituents, our maintainers, our members, our downstreams that use all of this great software cannot operate without having something like this, and how critical these types of things, the identifier and then the ability to kind of describe how the root cause works, these are critical, but even for upstream. And subsequently, we have been working on developing a federated neutral system. We're working with several other foundations. We're working with our board, getting feedback from people that have been deeply involved in vulnerability response for decades. And we are working on a plan to potentially release a new flavor of OSV that would be allow upstream to more effectively participate in the system. So getting better coverage of that 518 million projects, getting that data into the system, and then we can pipe that downstream to CVE, the Europeans, the Chinese, whatever consumers want to look at this data afterwards. Our first principles are it must be neutral and it must be federated. The data must be machine readable. You must have developer-friendly tools to be able to manipulate and evaluate that vulnerability data. It needs to integrate with existing systems, and it needs to support being able to report out on regulatory requirements like the Cyber Resilience Act, anything that comes out of NISA or CISA or international. And our biggest thing is I have a lot of conversations with folks like Greg K.H. from the kernel. It is very hard for upstream maintainers to be able to participate in the system. So we need to find a way to get these projects to be able to participate, to get you all the information that you can make choices. And they are in the same boat where they pick dependencies as well. They need to be able to have this information to make wise choices too. And we need to be more friendly to modern development practices. We can't wait 2 years to be able to use a Git-based system to share data with them. You have 2 years to implement that feature. And at public disclosure, all that information must be transparent, must be machine readable, and must be provided to all the stakeholders to evaluate. So I have like a minute or so, and if not, I'll be out in the hall. Does anyone have any questions? Anything I might be able to share more with you all? The which providers? Right now, we have been focused on talking with vendor product security teams. These are the people that are the bulk of the CNAs today. And we have most of them on board. They're interested in trying to find a solution for this because they also are missing a lot of data as they are building software for you. The scanning vendors, those are going to be a phase, once we actually start work, they'll be in the first or second phase. We start to engage with those folks. And that's something that we've done. I've worked at many vendors, and we've worked with these scanning vendors to help them understand like where the authoritative data is and really try to steer them away from NVD. NVD's okay, but it's just there's too many problems with that. And so we've always said that your best source of data for these scanning vendors is pulling directly from that project or that vendor's feed. So yes, they will be involved. We have not officially done anything yet, and we're hoping to get this kicked off probably in the next month or so. We'll start talking publicly about it and inviting people's participation. Pardon me? Part of the plan, we wouldn't necessarily get a regulatory endorsement, but part of the plan is for this project to become a CNA of last resort as part of the CVE program. So we would be able to participate as a first-class stakeholder, and from that, depending on what happens with these projects, which the funding theoretically is there till January. We'll see if that happens. We'll see if they renew that. But theoretically, being 100% compatible with those existing systems should allow the regulatory compliance. Basically, you have a vulnerability identifier. You have the data to be able to make your risk-based decisions.
What about like cross-mapping to say like, okay, well, CVE is still doing its own thing, Chat might be doing its own thing, you know, say like, okay, this is a thing, but this also maps back to these guys. You know, if they did.
So the question was, how would this integrate and do cross-mapping with other identifier systems? And OSV does this today. So that's where, again, we're looking at this open source project from Google, and it does 80% of what we need out of a system like this today, and it absolutely does the vulnerability mapping. It says this is the identifier in CVE, this is the identifier in GVE, this is the EUVD number. So we have that capability, and that will be part of this system. Right. No. And I've done vulnerability disclosure upstream for 15 years. I never dreamed that this would ever happen to this ecosystem. It never was perfect, but unfortunately, it is rapidly falling apart, and the fragmentation is a real risk for you all. Which database is important for you to look at? Where you're getting your information? And so it's important for my developers, my members, and just the whole ecosystem. So that's why we're working on this, and we want to try to be as compatible as possible with existing things. And working with scanning vendors and the whole like is all part of that plan. All right. Well, thank you all. I appreciate your time and attention.